Welcome back, learners. Today I'm going to introduce you to Graham's law of diffusion. In my previous lesson, we talked about diffusion, whereby we said diffusion is the movement of molecules from a region of high concentration to a region of low concentration. And we said this one, it happens in both liquids and gases. Take for example ammonia gas and HCl. So in Graham's law of diffusion, we want to relate, or we will be relating the rate of this diffusion in terms of density, molecular mass, and time. And the law states that the rate of diffusion of a gas, the rate of diffusion of a gas is inversely proportional to the square root of its density. So learner, how can you express Graham's law of diffusion mathematically? Please pause the video and try to express Graham's law of diffusion. So, as the law states, let the rate of diffusion be R is inversely proportional to the square root of its density, meaning if it is inversely proportional, it is 1 over x, of which this x is the square root of its density. So it is inversely proportional to 1 over square root, learner, not this, square root of its density, let it be d. Just to remind you, when we talk of something is inversely proportional, say y is inversely proportional to x, it is 1 over the x. You increase 1, the other one decreases. You increase 1, the other one decreases. When we talk of y is directly proportional to x, it means when one increases, the other one increases. A change of the other gives a corresponding or equal change to the other. So in Graham's law, if we are saying rate of diffusion of a gas is inversely proportional to the square root of its density. So from this equation, can we introduce a proportionality constant C? So it will be R is equal to C multiplied by 1 over square root of density. So with this, we can now combine and have R is equals to C over root D. So for instance, if we are comparing or we want to compare the rate of diffusion, comparing rate of A and B, it means the rate of diffusion of A will be equal to C, remember C is constant, no change, over root dA, density of A, and RB will be equal to C over root dB. Rate of diffusion of B, density of B. Rate of diffusion of A, density of A. Now at this point, you can see if you make C the constant, C, which is constant, proportionality constant of this one, the subject of the formula, you will have C is equals to RA root dA. Because this is the same as over 1, so you cross multiply. Over 1, so you cross multiply. And C will be RB density of B. Now at this point, you can see both in A and both in B, C is common. And it means this one is equal to this one. So we can express it and say RA root dA is equal to RB root dB. So let's make RA over RB be on the same side or be the subject of this formula. So it means we divide here by, so this should be RB, you divide by RB, divide by RB. So this one cancels out. We have RA over RB root dA is equals to root dB. So divide here by root dA, we divide by root dA. So this means you will have RA over RB equal to root dB over root dA. Learner, this is what we call Gram's law of diffusion, and if you are keen, you can note that rate of diffusion of A is inversely proportional to rate of diffusion of B, meaning Gram's law, we are correct in the derivation whereby we talked of rate being inversely proportional to the square root of its density. So, can we make this law, Gram's law of diffusion, or can we compare the rate of diffusion with molecular mass? We know density is equal to mass over volume, meaning density and the mass are directly proportional, or rather we can say density is directly proportional to the molecular mass. Remember, here we are talking of molecular mass, and therefore in terms of now Gram's law, we can be talking of rate of diffusion being directly proportional to the square root of molecular mass. So R being inversely proportional to 1 over square root of molecular mass. Let it be M. Molecular mass. So now at that point, if we are saying R is inversely proportional to the square root of M, if we derive it, it will bring us to this equation. But okay, we can derive together because it means R will be equal to C over square root of M, And for two gases, it will be Ra is equals to C over root Ma, and Rb, it will be equal to C over square root of Mb. So you make C the subject of the formula. It will be Ra square root of Ma is equals to C, and C is equals to Rb square root of Mb. At this point now, you can combine these two and have Ra root Ma is equals to Rb root Mb. So if you divide both sides by Mb, you will have Ra over Rb being root Mb over root Ma, the same as that of density. So in other terms, it is the same as density because you're saying density is directly proportional to the molecular mass. How can we introduce or rather compare the rate of diffusion with time? So for time, we talk of rate is inversely proportional to time. Rate being inversely proportional to time. And if it is inversely proportional to time, we can say R is inversely proportional to T. This is the mathematical expression of this now. Rate being inversely proportional to time. So if we introduce equal sign and constant, we'll have R is equals to C over T. And for a case where you have A and B, we can talk of Ra being equal to C over Ta and Rb equal to C over Tb. So combining these two, to make this is C Ra Ta and Rb Tb. So this is Ra Ta being equal to Rb Tb. So now we can make Ra Rb the subject, or B on the one side. It will be Ra over Rb. Remember, you are dividing both sides by Rb at this point, being equal to Tb over Ta. But remember, we had Ra over Rb being equal to square root of Db square root of DA, and also we had Ra over Rb being equal to Mb over Ma. If you look at the three equations, we have one, the second equation, and the third equation. Both Ra over Rb is equal to something, meaning these three equations are equal. So we can talk of Ra over Rb being equal to, start with the density here, root dB over root dA, which is equal to molecular mass of B over molecular mass of A. Remember, they are under root, which is equal to TB over TA.